welcome to Math Class with Karen. Today, I'm going to be telling you about my friend Katie's favorite math topic. Her favorite math topic is limits. When Katie was in calculus, she really loved learning about limits, and that helped her win a title for our school's mathletes against the Marymount mathletes. Or so I'm told. I was not there. But anyways, my friend Katie told me that limits are used to describe a function's behavior. So, as you see here on the graph, you can describe a function's behavior as it approaches a point instead of when it's on it. There are three kinds of limits. There are limits that are called left-hand limits, which approach point C from before it. And there are limits that are called right-hand limits. They approach the point from this way. Then there are limits that are like two-sided limits, and those take into account what the function is doing from either direction. Now, you might have heard my friend Katie say, the limit does not exist. And that was super epic because she won the title. But what does that mean? I didn't know what that meant either, so it's okay. Anyways, a limit exists when the function approaches the same point from both sides. So for example, right here, you see that function f of x goes towards the same point from here and towards the same point from the left-hand side. Cool. Also, the limit exists when the limit of x approaching c from the left-hand side equals the limit of x approaching c from the right-hand side. Cool. Now, let's talk about what my friend Katie was talking about. When a limit does not exist, which can sound scary, but that doesn't mean total oblivion. It just means that the function it's not doing the same thing from both sides, or there's discontinuity, or something really funky is happening. So, I'm going to show you an example of that. These are my glasses. So, on this side, we can see that the limit does not exist. Now, what does this mean? Well, if we go from the right-hand side towards -1, the function is at -2, right? It's approaching -2. However, when we come from the left, and they're approaching the same point, aren't they? No, they're not. They're not. I can do math. Anyway, when we come from the left-hand side, we can see that this is at y equals 0, not at y equals 2. So, the limit does not exist. This graph is actually really similar to the one that my friend Katie was looking at, but she wasn't looking at a graph. The graph was in her head because she was looking at an equation, which I still don't understand. But this is a graph. And so we can see why the Marymount mathlete thought that the limit was at -1, because if you look, you could be like, well, they're at the same point, but the function is not approaching the same point. And there is a jump discontinuity, because this is a piecewise function. Piecewise functions are hard. For me, at least. Anyways, a function can also be DNE if at one point it approaches infinity. Infinity is cool, but sometimes you can be approaching two different infinities, and then the limit does not exist. Because instead of being equal to positive infinity or negative infinity, you're going in two different directions. So it does not exist. There are also horizontal and vertical asymptotes that can also make it so that the limit does not exist. Math is scary. Anyway, here's why limits are significant to people like me. To people not like me. So, in calculus, limits help with mathematical analysis. They are used to define something called integrals and derivatives and something called continuity. My friend Katie told me those are real things. They're also used in real life by engineers when they have to study models of complex movement and make real life approximations. I like limits. My friend Katie likes limits. You should like limits as well.